Today I am taking a look at the PSA 6005 handheld RF spectrum analyzer from AIM-TTI. In this video I'm going to give you an overview of its spec, its features, show you it a little bit in use, and then at the end I'm going to give you my thoughts having spent a bit of time with this analyzer over the last couple of months. The PSA 6005 is a fully featured handheld professional spectrum analyzer. It features a frequency range of 10 megs up to 6 GHz, has a built-in battery for up to 3 hours portable use, and weighs just over 500 grams. It's fitted with a 4.3-inch LCD resistive touchscreen with a resolution of 480 by 272. This screen is not only used for displaying information and waveforms, but it also has a dedicated area at the bottom for adjusting many of the settings and features that are built into this analyzer. Below the LCD, you'll also find some dedicated hardware buttons, including the power button, some navigation keys, as well as dedicated function keys for the analyzer as well. Taking a close look into the main specifications of this analyzer, as I've said, it features a 10 MHz to 6 GHz frequency range. It has a resolution bandwidth of 300 Hz up to 10 MHz and has a 271 point sweep. It has a minus 120 dBm typical noise floor and can measure in dBm, dBm-UV, among others. It has a zero span mode with AM and FM demodulation, multi-trace modes, live view and reference trace modes, multi-marker selection, as well as a built-in frequency counter with a 10 Hz resolution. You also have various storage functionality, including frequency presets and an auto find feature that will actually lock on to the highest signal found when in use. You have unlimited storage with the built-in memory for waveforms and user assignable file names as well, and it has a USB interface for flash storage as well as a PC connection that allows you to display what you're seeing on the screen on your computer as well. It also has a comprehensive built-in help system that will give you information on all of the features of the analyzer too. Just taking a closer look at the actual device's hardware itself, on the left hand side you will find a mini USB port that allows you to connect it to your computer, which is also next to a USB-A port for host control when using it with external storage. As this device uses a resistive touchscreen, they have included a stylus as standard, and this is located in a small slot on the bottom right hand corner at the front. On the right hand side you will find the 5V DC input jack as well as the charging LED for both powering and charging the internal battery. On the top you'll find a trigger port, a headphones jack, as well as the main RF input. Now this is an N-type connector with a plus 25 dB max 50V DC input. On the bottom there's a small speaker, and on the back you will find an integrated stand that allows you to sit the device up at the perfect angle for viewing. This stand is also removable and it allows you to actually clip it on the front as a protector for the touchscreen, as well as a sunshade when using it out and about. Overall, this device has a nice, strong feel. The main plastics in the center are absolutely solid, and the grey areas at the top and bottom are rubber coated just to give some extra grip when in use. The next thing we're going to do is walk through how to actually use it and show you some of its functionality. Now I'm going to do that here on the bench, looking at some RF signals from radio control. So we're going to look at analog FPV on 5 gigs, digital FPV from the DJI system. We'll also take a look at some FHSS signals from remote controls, as well as some Wi-Fi stuff as well. Now, whilst I am concentrating on sort of radio control type signals, this is a fully professional spectrum analyzer and it can be used for any kind of RF work that you need a spectrum analyzer for, but today I'm more concentrating on the kind of stuff that I do on a daily basis. So what we're going to do next is jump in. I'm going to set another camera up so you guys can actually see the screen as I'm walking through it, and I'll walk you through how it actually works. So the first thing we're going to do is walk you through the functionality and then take a look at some signals on the device. Now, the device is split up into two sections, which is the LCD touchscreen and the main controls at the bottom. Now, these are basic function controls. Pretty much everything you do on this device is via the touchscreen. You can control various functions via these controls down here, and you can actually use them to move around controls on the screen, but the majority of stuff is done via the stylus on the touchscreen, but you do have the option for both. Now when we look at the display, we have our basic information at the top, which is our start frequency and stop frequency for the actual part of the band we're looking at. What that can also be is your center frequency and bandwidth, and we'll take a look at that in a second too. We've got our RBW and VBW. Now we'll talk about these in a little bit more in the video in a second. And we've then got our reference level and our divisions. We've then got our spectrum display, some more information in this area here, such as battery level, running start stop steps, and you do get some warnings and stuff appear in this area. And then we have our controls, and we have 3 layers of touchscreen buttons. The top is the main layer, which relates then down to the sub layer, which goes to the sub layer from there. So for instance, we're on frequency and span, which gives us all of the options for there, whichever one we've got selected here. So frequency presets gives us the options down here. If I was to select sweep and bandwidth, it would then give us those options, and you can see that all of the options change as you move through. So it's layer 1, then layer 2, then layer 3. Now to walk you through some of the basic functionality, so the first thing we're going to do is set the center frequency of what we want to look at. So we're going to take a look at the center, which is 2.4 gigs, which it currently is actually set to. So what I'm going to do first of all is jump to 5 gigs, and then we'll come back to 2.4. So we could set span, but what we'll do is we'll set center, set the center, and we're going to set it via the keypad. So you can do it 2 ways. You can set it via a keypad like this, or set jog and actually set it that way and move up through. You can also actually control this via these buttons down here as well if you wanted to, but I'm going to do it via the stylus here. So we're going to go back to keypad, and we're going to go to 5.8 gigahertz, click OK and exit, and as you can see, it's changed and it's jumped to 5.8 gigs. At the top, it's showing us 5800 with a span of 200 megahertz. Now, if we wanted to, we could change the span of what we're looking at. So rather than be on center, we can set to span, and we could then say, actually, I want the span to be 400 megahertz. So we type 400, click OK and exit, and you can now see the span is changed to 400 at the top. We can also control the span via a zoom in and out. So rather than actually type it in, we can simply just zoom out, and it will adjust the span as we want. You can also set the span to 0, and then that jumps into the functionality around that. We're just going to exit that back to normal. Now we'll then jump back to the center, and we're going to put it now back to 2.4 gigs because we'll look at some signals as we're moving through. So here we've got a couple of options. Again, as I said, we could set center. We can even do step up and step down if we wanted to, but the simplest way is set center. We're going to go 2400, click OK and exit. And that's going to then take us back to 2004, which is my current Wi-Fi band. As you can see now, we've got some signals appearing on the display, and this is the Wi-Fi that the analyzer is actually picking up here and now. Now, as I've said, we've already seen the option to set the span, and it's currently at 100, but we will take that out a little bit. We'll set it to 200. That way we can see some of the other signals coming across here. Now, what I think we will also do is actually move the center up a little bit, because these signals are slightly off to the side. So what I'm going to actually do is just adjust the center a little bit, just to move it up, and we can bring them closer in. I think what we'll do is we'll go 2410. That will probably get us a little bit closer. Yeah, they're more in the center now rather than coming up off the side of the display. So we've got our center frequency, we've got our span. The next option across is start stop, which is just telling the analyzer to start or stop. We've got our step size. So here we can tell it what we want it to step in when we're making those adjustments. And then we've got our frequency presets here as well, which allows us to full span of the entire band, or you can actually store presets, that sort of common frequencies that you're used to looking at when you're using the device. Moving over to the sweep and BW menu, this is where you have some of the more complex options around having a spectrum analyzer. So we've got our RBW and VBW settings, which we'll talk about in a second, our options for sweep time, sweep control, sweep mode, and detector type. And again, this is some of the more complex options around the analyzer. Now, RBW and VBW are the two real main things that people need to play with or set when you are looking at a signal. Now, I'm not going to dive into what the difference between RBW and VBW is. RBW is basically the window the scope uses to actually look across the band. So for instance, we've got an RBW of 1 megahertz. There is a really good video on RBW and VBW, and I will put a link to that in the comment section. If you're interested in learning more on that, do check it out, because it does explain it in much better detail than I'm going to do on this. Basically, RBW is the bandwidth that it's looking at as it's sweeping through. The wider it is, the faster it can sweep. However, then it loses resolution, which means it can miss small signals or group small signals together as one, whereas a smaller RBW will look at much more detail as it's sweeping the band, but it takes longer. And there is always a trade-off between one of those two settings. You want the lowest possible, but with the fastest possible sweep time, but depending on your application will depend what you need to set it to. So anyway, we'll take a look at what the settings are. So we've got our RBW auto and RBW set. So if we click RBW auto, the scan analyzer will simply go and have a look at what it thinks is right, and it's now set it to 3 megahertz. We can though also set the RBW manually, and to do this you simply click RBW set, and you can go from 10 megahertz all the way down to 100 kilohertz. Now, as I've already mentioned, we're currently on 3, which gives us a sweep time of 0.15 of a second. If I reduce it down to 1 megahertz, you can see we've increased the sweep time to 0.34. However, the signal will have a bit more resolution now. Or if I, for instance, set it to 10 megahertz, we'd have the fastest sweep time, but you would lose the resolution in those very close radio signals. So again, you're always on a trade-off here, what you want versus what kind of signal you're looking at. For me now, for this, we're going to set it at 1 megahertz because I'm happy with the 0.3 scan time, and that's going to be okay. We've then got our VBW and VBW set, VBW track and set. Now, VBW is your video bandwidth filter. Now, this is a filter that is similar to the RBW, but it doesn't actually affect the radio signal itself. It is often known as a smoothing filter, actually, to the signal, and it's all done after the processing is done when the signal is received in the analyzer. It doesn't actually have an effect on the actual signal. It's simply how it affects how the signal is interpreted and shown on the display. Now, the nice thing again about VBW is it allows you to actually smooth the signal out and just help get rid of some of that noise around it. So for instance, if I go to VBW track, you can now see that the signal is much more noisy. Whereas if we go to VBW set, we can actually set this right down, and we could actually set this down to 10 kilohertz. And you can see that it's smoothed everything out, and it's handy to help you actually look at signals that might be hiding in some of that noise at the bottom there. However, it does have some trade-offs as well, but again, you've got the settings for that all listed down the side, or you can simply go track, and it will then track the option depending on what you want it to do. Now, as I've said, I will put a link to a great video on this. I'm not going to go into it in any more depth because it's an extremely complicated subject in itself. But if you have used an analyzer before, you will know the difference. And again, it all depends the kind of signals you are measuring, whether they're fixed signals, whether they're frequency hopping, and trying to then set the best RBW versus VBW for your application. Okay, moving then over to sweep time, allows us to set the sweep time on the device. It's currently set depending on what the RBW is, and I'm just going to leave it at that. We've then got our sweep control, which allows us to set the kind of sweeps. So repeat, single, sweep trigger, single arm and scan mode. We've then got sweep mode, whether it be auto or manual. And then we've got our detector type options, which allows us to set how it will actually detect the signal. So for instance, you've got default is positive, or we can set our detector type, which is RMS, alternate peak, log average, linear average, sample, negative or positive. We're going to leave it on positive for what we're looking at today. Moving over to levels and limits. Now this is where we would set our reference level for the analyzer, as well as the limits and how everything looks on the display. So the reference level is obviously the point from the top of the display down, because you always are measuring a radio signal like that, unlike an oscilloscope that you're measuring from, say, a ground reference up, unless you're going into a negative signal, whereas an analyzer is from the point at the top down. So here we can set our units, for instance, so we can go dBm or dBmV, and we can also then set what we want it to show on them. We've then got our reference level, and this is again the reference point from the top of the display down. So at the moment it's on minus 25 dB. So we can either go plus and minus and set the steps for that plus and minus. So for instance, we can go to 5 dB increments. We can then go down or up. So if we went to reference of 0, we can do it that way. Or we can set it via the on-screen controls. Again, you've got the option to set it via the keypad input. So again, we can say 0 and exit, and then it will set it to that. And as you can now see, we've got a reference of 0 at the top, and our signals down here are about minus 60. And as they're quite far out now, we're no longer seeing them as clear as we were earlier. We've then got our scale and shift. So again, we can set the scale. So this is the increments on the side of the display. So we're currently in 10 dB divisions. We could set it to 2 dB divisions if we wanted to. And now you can see that's changed, and we've then got in a lot closer on that signal. And then we can then use the shift up and down to move it about on the display where we want it to actually be. So again, we can shift it up as well. And again, depending on these settings, you may then need to go back and check your RBW, your VBW to be able to try and get the signal to look as clean as possible. We're going to go back to the normal 10 and set it there. We've then got our offset tables, which allows us to do some more complex options. Sorry, let me go back to there. Offset tables, that allows us to do some more complex. And then we've got our limit options as well, so you can set limits around the signals as well. Moving then over to traces and markers. Here we can actually use some of the real interesting bits that you have on an analyzer, which is your markers that allow you to set markers on the display, so you can mark what you're looking at and actually get some information from that. So for instance, we can turn on our markers. They're currently active, and marker 1 is currently at 5750. We can then go marker center, and that will actually bring it straight back to the center frequency that we have currently on the display. What we can then do is actually move the marker with the buttons at the bottom, and if we want to then turn on the second marker, we can then press that again, and it brings on the second marker, which is in blue. And you can also control these via this little button here. So for instance, if I press it, they've both gone off. Press 1, press 2. And then you can see on the display, the markers actually show the information about their frequency, as well as the signal at that point as well. So again, if we wanted to put the marker on one of these closer signals, so what we'll actually do now is we're going to go into here, we're going to set our RBW, VBW. We're going to set this now. That's at 1 meg. So we're going to set our VBW, come out of that, set our VBW a lot lower. We're going to go down to 30 kilohertz. Things will look a bit clearer now. So we can now set one of our markers right on top of one of these signals as it's coming on there. And then you can see now that the markers jump in from sort of minus 40 to minus 50 when the signal appears. But we can then also set the bandwidth, because you can then see we've got one marker here, one marker there. So we've got our start and stop. So again, going back onto that. We've then got our tracer modes. So we can turn traces on and off. So if you click view, you'll see a white appear on it, and that is actually the trace being left by the signal. So you can see where the signals actually peak to, and that leaves that actually on the display. So what I can actually do is, if I turn live off, you can see the traces now left from the actual signals itself. Or we can turn the live on. You then got the trace mode, which you can set. So you've got normal, peak, hold, average, reset. So for instance, we've got it on normal at the moment. We can go to peak hold, so it'll actually hold the peak of the signal depending on what it goes to. We then got the marker setup, which allows us to do some other stuff on the markers. So we can select marker 1, marker 2, turn them on and off. The units, sorry, you've always got to come out of a menu. If you've gone into it, you've got to come out of it before you can move on. The units, the function, so counter on and off, peak mode, etc. And then some other options around the markers here as well. And then finally, you've got the marker control, which again, it allows you to do what we did just now. So we can set it manual position, turn them on and off, manually set, all of the usual functionality that you would expect to find around them. The final option is the setup and functions menu over here, and this is where you have some of the other functionality around the device, such as the logging. So it allows you to log to that onboard memory, which is included. The auto measure function, which will scan the band and automatically measure and set it to the strongest signal, basically, depending on what is around you. Now, you wouldn't really want to use that one out and about, but you can use that here. There's a frequency counter function built into the device as well, so we can actually use a frequency counter with this, and it will actually give us an idea of what the frequency is. So again, if we go into frequency counter, you can toggle it on and off, so you can see the frequency counter being displayed down there. And then we've got our setups option, and we'll go into that in a second, on our system and file utilities options, which is the settings around how you want it to handle the files that it stores, as well as the system utilities as well. Now that is all of the basics covered. What we'll do now is take a look at some signals, and I'm just going to walk you through looking at some radio signals and just showing you the settings on the display as well as we do them, just how to get the best view of what you want to look at on the display when you are using the analyzer. So the first signal we're going to look at is from the T16S, which is the main radio control signal on 2.4 gigs with an FrSky X8S receiver. Now there are two signals at play here. You have the signal from the transmitter to the receiver, and then you have the telemetry signal coming back. And we won't really be able to distinguish the difference between them today, but it will give you an overview of what this signal actually looks like. So the first thing we're going to do is power that up. We're going to power on that receiver. I've already done the binding on this, so it will connect okay. And we'll just wait for this all to kick in, get past all the warnings. I may need to put a bit of distance here because you always do get that issue. Failsafe not set. Yes, 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 yes. Okay, so now on the display, you can see some new signals appear that weren't here before. Now these are those FHSS signals. Now what I'm going to do is just bring this in a little bit closer, just so the amplitude comes up on them compared to the Wi-Fi signals. Let me just tighten that and shift that there. And you can now see them showing. Now, to be able to show these a bit easier, we're going to speed everything up a little bit, because the RBW filter will be slowing our time down. We're down at 0.34 seconds, and we want to be a bit quicker because these are very fast moving signals. So I'm okay with the center frequency. I've got no problems with that. So what we want to do is we're going to go into the filters. We're going to set the RBW to auto a minute, and you can see now that that's come in at 3 megahertz, and you can now see those signals moving through. We're also just going to set the levels a little bit and set the reference level, and we're going to set it at -20 just to get things a little bit down the display, and it will allow us to actually look at things a little bit easier. So you can see we're getting the ADC overload because it's really close to it now. Let me set the I think I'll probably set it a little bit -10. Let's see what that's like. There we go. It's probably still a little bit strong. Let me just move him out a little bit. That'll give us a bit of space. But as you can see on the display, you're now seeing those FHSS signals bouncing around. Now, if we hop into our VBW settings, and we'll take it down to like 1 kilohertz, it will speed things up, but that actually allows you to see it a lot easier on the display, although the sweep time is a lot slower. But you're just seeing each of those signals from the remote controller move and bounce around the display because it is a moving frequency. It's not in one place, it's on the move continuously. Now, the next thing we'll look at is an analog FPV video signal. Now the nice thing about this is it's a nice static analog video carrier. So I've got a traditional VTX here, 5 gigs, nothing particularly special. We're just going to plug it in. There's not even a camera attached to it, but we don't have to worry about that. We're just going to turn that radio off as well, because it's going to still send the video carrier. So we're still going to see everything we need to see, even though that there's no camera on it. Let me just plug it into the balance port and power it up, and then we'll jump on and take a look at on the analyzer. Okay, so now we should be powered up. Now, first of all, we're on the wrong band because we're on 2.4 gigs. So what we need to do is jump and change the band. So we're going to go center, set center. We're going to go to 5800, and we're going to start there. So you can now see a carrier has appeared here, which is the video carrier from the transmitter. Now, if I just bring it a bit closer, you can see it's actually showing this. So what we now need to do is get in a lot closer. So let's zoom in, and we can see it's up by here. Now, if we wanted to, we could bring the marker to this, so we could see it nice and easily. So if we just go to our traces and markers, marker setup, marker control, sorry, marker to the center, which has brought us here. And what we can do now is move it up, and we can have a look at what frequency we're on, and we can set that then to our center. So again, that's 5845. So if we want to, we'll just go set center 5845, click OK, and boom, there we go. It's in the middle now. Now, it's still quite small. If I turn the marker off, it's still quite small. So what we're going to do is come in a bit closer. We're going to set our levels a bit better for that. So I think we'll go -10. See how that looks. Cool. We're coming in closer, and you can see now that signal much better. You've got the main video carrier there. It's in a nice position on the display. I think we'll come in one more, -30. We might get away with that on this one. Yeah, we have. Yeah, we have. So, okay, so we've got it in, and you can now see that video signal nice and clearly in the center of the display. If we wanted to get in, we could set our scale a little bit. So let's go to 5 dB, and now you can see the bottom end of the signal here with the top end of it coming off the display. And if we wanted to see the top end, we can simply bring it down. Have a look there. Again, if we just, I think what we'll do is we'll just adjust the reference level ever so slightly to -25. And that should, or 22 as I've set it to, that's just allowed us now to get that full signal on the screen. Now, because this is a nice fixed video signal, it's showing nice and easily. So we could have on this a much faster filter because the signal isn't moving. So we're not going to miss anything with a slower sweep time. It's currently sweeping at 20 milliseconds. So if we wanted to, we could actually go down here. We could set our RBW to auto and our VBW to track, and we'll just see what it sets them to. You can see that it's there. So if we set our RBW to 10 megs, this is a really nice way of showing you what I meant about it not showing the individual signals. So let's just take our bandwidth out a touch. Sorry, our reference level down a touch. One more, I think. Okay, so this is what I was explaining earlier about our resolution filter, okay? It's currently set at 10 megahertz, which is showing our big lump, which is our video signal, but it's not showing it at a very high resolution. Now, if we come down to 1 megahertz, you can now see the signal is actually different. It's a much thinner video signal, and there's actually 2 stronger ones either side. So if we just clear this up, because remember our VBW is more of a smoothing filter. So if we put it at 100 kilohertz, there we go. It takes that noise level down, and you can now see in more detail the signals either side. We'll do it actually further than that. Let's take it down to 30, and that should give us a nice clear view. So what you can now see on the display is our video signal in the center with the harmonics either side. Now, you wouldn't see that when we have a wider resolution bandwidth filter. So for instance, if I set that now back again to 10, it's just seeing it as one big signal. Whereas when you have it smaller, so if I go down to here and we set it to 30 kilohertz, you have the signal much clearer than we had before, but the sweep time increases. So this setting is always a game of what is the best setting depending on what your application is. So in this application, we can have it here like this, probably a bit, go to 300. 300 might be a nice middle. Yeah, 300 looks a fairly decent middle ground. We're seeing the strong video signal in the middle with the peaks either side. We're a bit low. It's not quite on the display where it needs to be. But again, for looking at it, 1 megs is probably a nice spot. And that shows us a nice sweep time of 0.2 of a second. And we're getting the signal nice and clearly on the display. So again, it's nice. It's showing us that signal nice and easy. Now, I'll use this to just quickly show you the auto function as well, because it's nice, strong signal, and it should pick it up. So if I just set the center now to 150 megahertz, just something completely out the way, okay, which I've done. So what we'll do is we'll press our button down here and click our auto set, execute, and this then will do a full scan from 10 megahertz to basically 6 gigahertz out of all the signals, and then it should land, all being well, on our video signal, because this is the strongest one that we've seen on the band. So as you can see, it's finished, it's done, and it's landed on the video signal. Okay, so the last signal I'm going to show you from an FPV point of view is this, the DJI Digital FPV drone. Now, I've done a number of videos with this already showing this, but I am going to show it in here quickly as well, just to show you it on the display. Now, I'm going to move this across there out the way because it's bloody loud when it's turned on. Now, this is currently set to 5.8 mode, but what is interesting is the remote controller remains on 2.4, so we've actually got 2 different frequencies going on here at the same time. You've then got a video transmission, which is an OFDM digital video transmission from the drone to the goggles. You've got an FHSS signal from the remote to the drone, and you've then got a telemetry link from the goggles to the drone as well. So there's actually multiple paths of signal going on here. So what we're going to do first of all is just put that by there out of the way. And what we need to do first of all is to find that signal itself. It's set to 5 gigs, so we need to figure out where that one is. Now, we've got the span really low on this at the moment, so what we're going to do is we're going to span out. But what we could do again is do that auto set and let it do the scan, and we'll just see if it picks it up. I've not actually done it this way yet with the DJI drone, but it should pick the signal up, all being well, but it will depend what it sets the span to, because it is quite a big signal. It's currently set to 20 megs bandwidth, so it's not the smallest, but it's certainly much bigger than that signal we were seeing on the analog FPV. So it's come up to here. I'm not sure what it's actually found, so let's do this manually. So we know we're up here. We're going to take the span and we're going to take it right out. We're going to take the span out to 200 and see how that actually looks. Then we can see that there is a signal there in the middle. Yeah, it's definitely there. I think what we need to do is clean this all up a little bit. So we're going to set the RBW to there. We're going to just move the goggles away slightly, and you can now see things open up a little bit. We've got a signal down here, a signal here. I think we'll just set the bandwidth a little bit more to 500. It might be a bit, that's better. Okay, so we can now see a couple of things. We've got a video signal here, and then we've got this random trace appearing here. That is actually the telemetry link from the goggles back. So if we let's clean things up so we can actually see things in a lot more detail. So let's go to 30 kilohertz on that. There we go. Now we can start to see things a bit easier. We've got the video signal and we've got that there. Now what we want to do now is we're going to come in a bit closer because we're certainly too much on the span. We know the center now for the video is there, so let's come in a bit. Okay, we need to shift the center up a little bit, so let's shift the center up. We could set the center to the peak, which is that. but it's picking up that individual signal there. Let's just see if it does it this time. It's going to be a hard one to do that because that random one is actually a bigger signal than we're seeing there. So we're going to set it to M1. Quickest way of doing it. There we go. So now we've got it set there. And this now is our FPV OFDM video signal. Again, we could set that to 3 megs, which might be a bit quicker, and you can then see the individual signals, and that is that OFDM mass. If we set our levels and limits, let's shift it down, and I think what we'll do is we'll set our scale to 2 dB, and we want to shift it up so we can get in a bit closer. It'll appear now in a second. There it is, and you can then see that large video mass from the OFDM signal on the DJI FPV. Now, for instance, if I change the bandwidth on this now, so I'm just going to look in the goggles to do this, you'll be able to actually see that change on the display. So it's currently set to 20 megs, so I'm going to set it to 40. You can now see the width of the signal is increased dramatically. It's a much bigger signal overall. If we just change this so it doesn't quite look so individual, there we go, and you can see it more as a mass now I've done that. And if I now set it to 10 megs, you can see it becomes a much slimmer signal overall compared to setting it to 20. You can see it widening up, and then 40 from there. So there it's at that full bandwidth. Now you can see off to the side here a signal appearing every now and again, and that is one of the transmissions from the goggles back to the drone. So for instance, if I bring the drone closer to the aerial, you can see the signal increases dramatically, or if I bring the drone further away, you can see that the signal goes down. If I bring the goggles closer, you can see this signal up on this left side here is peaking much higher, and if I bring the goggles away, you can see that signal gets much lower. You know, it's barely showing at times there now. Over the last month or so, I've also had the analyzer out on multiple occasions, looking for RF signals in the areas I've been flying. Now, if you're going to do this, you really want to get yourself something like a good, high-quality directional antenna that's going to give you plenty of gain and help you actually pick up any of those weak signals that might be going on out there. But I've used it when I've been out flying with the FPV drone, as well as my Inspire 2 when doing some commercial ops as well. And overall, it's been really handy to have a device like this with me to be able to make sure the area that I'm working in or the area that I'm flying in is absolutely safe from an RF point of view. So, to give you my thoughts on the PSA 6005, now I just want to say up front, they have very kindly lent me this device to allow me to make some content on using the device with other systems. So for instance, I've used it to learn how the DJI Digital FPV system works. I've used it to try and understand how some of the other systems work. However, that won't influence what I think about it. I've not been paid to make this video. Having spent a month and a half with this device, I have to say I absolutely love it. In fact, I'd probably give a limb to own this device. It is a fully fledged professional tool. It is not a low-cost budget version of a spectrum analyzer. It is basically a fully fledged analyzer in a portable package. With regards to this actual device and what I think overall, I love it. It's brilliant. It does exactly what I expect it to do. About the only one or two downsides I will say is this: it's a bit slow when using it with the PC functionality. At times the touchscreen can lag a little bit. I think a few people would prefer more buttons than touchscreen functionality, but it's a trade-off on a device like this because there is so much functionality to pack in. A touchscreen really is the only way forward. It really feels like a professional device. It's tough. It's heavy, but not too heavy. The touchscreen as well is of that kind. It's not just going to damage easily. It's a proper professional tool. Now, for me, It's been fantastic to have this device on the bench. In here, it's allowed me to do stuff that I've never been able to do before, such as look at the DJI FPV systems. We made a video on that if you haven't seen it, looking at how that system actually works. And I've been able to dig into many of the other RF systems that are out there that we use as well. And I have got some more videos coming up showing you some of the others using the analyzer as well. Really, if you're a professional, a commercial operator, or someone that needs a professional tool out and about, this is well worth a look. And again, please do check out the link to ATTI's website. Now, that is it for this video. I have to say again, a massive thank you to ATTI for loaning us this one. It really has been a pleasure to have on the bench. If you'd like to support the channel, please do consider hitting the subscribe button if you have found this video useful. Also, don't forget to hit the little bell next to it as well. That way you will get updates when some of the other videos come out. If you'd like to support the channel to allow us to keep buying equipment like this, for instance, there are links to buy me a coffee as well as Patreon in the description of this video as well. Finally, please do give me your thoughts on what you've seen in this video and this device. I'll also put a link to that other video I made as well. And as I've already said, there is more content to come with this too. So please do again hit the bell. That way you'll get the updates when they're ready to be released.